financial stuff, risk, then you all who would take a higher degree of risk and a higher degree of variation, because again, you're investing over a much longer time frame. So you can let those things average out. So that's what standard deviation is asking about. It's asking, how packed around the mean is my data set? When I look at my data set, I look at the values of my data set. How close are my observations to the mean itself? Now the formula for standard deviation is as follows. So I do want you to see this formula. Now the formula for standard deviation is it's the square root of the summation. Sigma is the summation of xi minus x bar squared, all divided by n minus 1. Now, you're not going to actually use this formula per se in terms of I'm not going to make you actually go out and find out what x bar is and subtract x bar from each x and square them and add them all up and divide by n minus 1. But it is a formula that we see again, so I want you to see it. But what we're going to do is we're going to take each observation, okay? So each piece of data in our data set, and we're going to subtract the mean. How far away from the mean is each observation? We're going to square that difference. The reason we square differences with standard deviation is we want to get rid of pluses and minuses. Okay? The idea of being 1 above versus 5 below, you'd rather be at the 1 above instead of 5 below. So by squaring it, we get rid of positive and negative signs. We're going to take that difference, that square difference, add it all up. We're going to divide by n minus 1. We minus 1 from that because of degrees of freedom, and that we've actually used x bar, which we've already estimated in our equation. We're going to divide by that, and then we're going to take the square root because we've already squared things, so we want to get that into a normal term. What standard deviation represents is it represents the average difference between an observation and the mean. What is the average difference between an observation and the mean? The larger your standard deviation is, the further your data is spread away from the mean. So in this case, here we have price. We have the mean, 97,992. If you go down here, you have variance. Variance and standard deviation are related to each other. Variance is just the square of standard deviation, or standard deviation is the square root of variance. Variance really came into play because it's easier to calculate when you're doing it by hand. But using computers nowadays, we always go with standard deviation. So standard deviation in this case is $26,429.53. So what this says is that we think the average house sells for, in this case, $98,000. The average house sells for $98,000. But the variation on these houses is off by approximately $26,429. So it would be very typical to see a house that was, anywhere from 1 standard deviation below to 1 standard deviation above. We actually think that pretty much 95% of our data is within 2 standard deviations. So if you were to take that standard deviation, multiply it by 2, you'd get about 53,000. And what we could do is we could add and subtract that to the mean, and most houses should be in that range. Subtracting 53,000 from 98, adding 53,000 to 98. And that would give us, in this case, where we would think about 95% of the houses are located in terms of price. So standard deviation is a nice measure. This is one reason why I was talking about when I gave back your test. I was talking about there was a curve. I was looking at standard deviation a lot. Because this is going to give me the idea of how spread out was the class on that exam. And that was sort of going to be how I was going to judge where A's and B's and C's were going to be located. So we have standard deviation. That's a nice measure. It's always in the units of whatever the variable that you're talking about is. So in this case, standard deviation is $26,000. Same thing with the mean. The mean is $98,000. If I'm talking about the age of the house or square footage of the house, I'm talking about those are all measured in square feet. Any questions about standard deviation? Everyone okay with it? Standard deviation also brings us up to the idea of outliers. Now, in the Elway case, it was easy to determine what an outlier was. Yeah, you're seeing all these people that are earning 20, maybe some with 30,000, some in the teens, and then you see 6 million. And it doesn't take a rocket scientist or something like that to say that the 6 million doesn't fit with the rest of the data. But how do you find outliers? Like if you were to look at this data set of housing prices, okay, we see that the min here is 59,000 something. The max is 195,000. Is that an outlier or not? Okay. 195 doesn't look too unusual, but is it unusual? Okay. And so what we're going to say with outliers, as an outlier is any